Hello friends, welcome back to our channel. Now this video is just going to be a revision kind of thing. You have already studied many concepts in your first year of electrical engineering. So we are just going to apply all those concepts over here so that we'll just have a quick revision so that we can move forward for our gate and IAS problems. Although sometimes simple things, simple topics comes in gate or in your IAS, but because we tend to solve problems which are very difficult, we have this general notion that gate problems or IAS problems are actually very difficult. But no, if you are like your basic concepts are clear, then you can very easily clear gate or IAS exam. So let's start with our problem. This is the diagram given here. You have to find x. Okay, before starting, please do subscribe to our channel for such educational videos. And yeah, let's get started. Now for finding x, what you have to do, which rule you are going to apply on this? Do you have any idea? Yes, of course, you have studied that rule. It is KCL. Do you remember this? Kirchoffs law. Okay, current law. Now, what does this say? Your incoming current is always the summation of all your incoming current is equals to the summation of your outgoing current, right? So from the diagram itself, it is very clear which all currents are the incoming current. The 7 ampere is your incoming current and the 6 ampere is your incoming current, right? So as we said, your incoming current is equals to outgoing current. Okay, the sum of, you can write sum of incoming current is equal to sum of outgoing currents. So basically here you can see this is your incoming current, this one is again your incoming current, right? So 7 plus 6 is equals to 2 plus x plus 20. So from here you get x equals to minus 9 ampere, right? So if it is coming minus 9, don't get upset that is our answers is coming wrong. It is just that the sign convention that you took or that is given in the problem is of opposite direction. If it is like this, it should have been in this direction, not in this direction, nothing else. Okay, so don't get scared of such negative markings. Okay, I mean negative signs on your answers. Okay, so let's move on to another problem. So now this is another question. In this particular question, they asked you to find V of x, Vx, and that is voltage across this area. So the current mentioned over here is 5 ampere. Okay, now by looking at this diagram, you can very easily say which which theorem you are applying, which law you are applying. Yeah, it's KVL. Now what does KVL say? It says that the summation of all the voltages in a loop should be 0. Mesh or loop should be 0, right? So now let's see. The first voltage is, let's do summation, minus 10. Now of course this voltage will take, but the voltage across this 2 ohm resistance is also necessary, right? So minus 10, and your current is flowing the current which is flowing is 5. Here there is a gap, so this current itself is flowing in this whole circuit, right, everywhere. So minus 10, 2 into 5, again minus 10, then okay, because 2 into 5, now we are coming to this part. Okay, so yeah, we are coming to this part now. 1 ohm. Now tell me, should we multiply 1 ohm with 5? No, because this part is open, right? You can see here it is open. So the current basically which is flowing through this branch is 0. So therefore this will be, you write minus, you write plus, whatever, it is 0, right? Now then we are coming towards 4, right? So this will be plus 4, and then again from here to Vx, so it will be Vx, and that will be equal to 0. So from here we get V of x is 16. Okay, I hope you have got the concept very clear. You're taking the path like this. Okay, so minus 10, 5 into 2, this current, 5 into 2, minus 10, here no current is there in this branch, so it will be 0, plus 4, okay, and then plus Vx, that is equals to 0. So your Vx is 16. Okay, so there's another problem here. As you can see, they said we have to find E1, V1 and V2. Now this one is given as 0 over here, right? So what will be the voltage drop for finding E1? It's E1 or E, whatever you say. So let's write it E1. Okay, now this is basically grounded, right? So now we have to find E1. How can we find? What will be the voltage drop across this? Tell me. So the voltage drop across this will be 10, 0 and 10, right? So if you subtract it, it will be obviously be 10, and your convention will be like this. So from here you can make it as a closed loop now. Okay, so apply KVL over here. So if you apply KVL, what are you getting? You're getting minus 8 minus E1 minus 4 minus 10. So yeah, all the voltage sources we have taken, 8, E, 4 and your 10, that is always equals to 0. So from here we find that our E or E1, whatever it is, coming minus 22 volt. Correct? Don't worry about this negative sign. It is correct. Okay, so don't worry about it. You have taken the sign convention differently. So yeah, don't worry about it. Now we will find V1. Okay, so to find V1, let's again close this. Now here we don't know which one is greater, V1 or 10, because we don't have the value of V. We have to find it. So let's take it. Now this will be, let's see, let's suppose that 10 is greater. Okay, so 10 minus V1 we are going like this, minus 6. Okay, we are going like this, 10 minus v1 minus 6, and here plus 8. I hope you understand the sign conventions. 10 v1, this negative this minus 6, and then 8 positive. This is equals to 0. So you have taken all the voltage sources over here, 10 v1 6 8. So your v1 is, how much will be your v1? It is going to be 12 volt. Okay, now let's find v2. Again we have closed the circuit. You can also find v2 from here, but this will be more easy, so I'm just doing like that. So here this portion is totally v2. Obviously from 0 to v2 the difference is v2. So let's write 4. We are going to this 4 minus 2 plus v2 is 0. So your v2 is coming as minus of 2. So if you would have taken the other way, then it would have come plus 2, but it's okay. So yeah, don't forget to write volts obviously. So with this we did some revision of on KCL and KVL problems. So yeah, thanks for watching our video, and don't forget to subscribe. Ta-da!